So first thing, what is atmosphere? So atmosphere, it is a layer of gases that surrounds the planet. It's like a skin of apple, and these gases they are held by gravity. And as you go up, the density of the gas also decreases. So mainly it contains nitrogen, oxygen, carbon dioxide. Nitrogen, oxygen, and inert, those are many important gases. Then other constituents are carbon dioxide or water vapor, methane, all are found within the atmosphere. Those are very important thing. So atmosphere is very important for life form. So it regulates the temperature. It protects us from the solar radiation. So without, you can say, without atmosphere, our Earth's temperature will be very less because atmosphere absorbs or it radiates solar energy so that it will regulate temperature. Another most important phenomenon that occur within the atmosphere, that is weather. So weather occur within the atmosphere, and that also helps to regulate or facilitate the life form within the earth. Then it also facilitates respiration because of the availability of oxygen. It helps in photosynthesis from carbon dioxide, and it also shield the planet from meteorite impact. So meteorite, they have friction with the atmosphere, so they burn within the atmosphere. So that's how atmosphere helps the life form within the earth, and very a vital important part of the earth's biosphere, you can say. So today we'll study about the composition and layers of the earth. First we'll start from the composition of atmosphere. As you know, atmosphere consists of gases. So there are different types of gases. जैसे परमानेंट गैस हो गया, वेरिएबल गैस हो गया, ट्रेस गैस, और छोटा पार्टिकल जैसा होता है एरोसॉल, वोल्केनिक से आता है, डस्ट पार्टिकल होता है. So all these are the component of the atmosphere. So permanent gas मतलब कि the gases, the amount of the gases is constant throughout the time. That is oxygen, nitrogen, and inert gases like your argon. So you know oxygen is 21%, nitrogen is 78%, and 1% constitute all the inert gases. And from that, argon is the major one, which comes from the volcanic eruption. Then variable gases whose composition changes with time, like you can say carbon dioxide, it changes with time, with anthropogenic impact, human impact, or with uh, different industrial evolution. The carbon dioxide amount changes. Water vapor is also, it is not a variable gas, but it is a component which changes with time. But these three is always these three are always constant within the atmosphere. So this is the detailed analysis of composition of different gases. So these are variable gases, these are permanent gases. So in permanent gases we have N2, O2, then argon. Once. So in permanent gas we have only three major part, you can say nitrogen, oxygen, argon. Then all other are very less amount. Then in variable gas or particle, we have water vapor, which is approximately you will find 0.25%, or it varies actually. So it varies from 0 to 4. Then we have carbon dioxide, we have methane, which is very helpful to recover ozone layer. Then we have nitrous oxide, then ozone. Ozone is also very important because it helps to protect the UV rays, to absorb the UV rays. Then we have some dust particle that from volcano or that from pollution, a different pollutant is also there. So those are also variable particles. This comes to the nitrogen. So nitrogen primarily occur within the atmosphere as N2. It is present 78% by volume and 75.5% by mass. So into it cannot be directly used. So directly use नहीं कर सकते हो. There is a process called nitrogen fixation. Nitrogen fixation. By this process, atmospheric N2 comes to the terrestrial part. नाइट्रोजन फिक्सेशन प्रोसेस से N2 कन्वर्ट होता है ऑक्साइड्स में एंड इट कैन बी यूज्ड बाय लैंड प्लांट्स और एनिमल. N2 is also very primitive. It is present from the formation of the atmosphere. Then comes to oxygen. So oxygen is the second most abundant, constitutes 21% by volume and 23% by mass. It is obviously very important for life form because we take oxygen in respiration. So O2, it was not initially abundant, or it was not initially 21%. It rose up approximately 2.2 billion years ago, which is after the starting of photosynthesis. So O2 and nitrogen, from O2 and nitrogen has greater, you can say, resident time. It can remain within the atmosphere for longer period than oxygen. Oxygen has a very less resident time. You can say approximately it has a resident time of 6,000 years. Resident time is how many days it will remain within the atmosphere. So N2 has resident time in million years, and the largest resident time is of argon, because argon is inert. It doesn't form any compound with any other substances, so that it will remain within the atmosphere for a very long period of time, greater than, you can say, nitrogen. So these are the characteristics of nitrogen and oxygen within the atmosphere. Then water vapor is from 0 to 4%. It can exist in all phases, solid, liquid and gaseous phases. So it is also very important for cloud formation. It also regulates the temperature, and mostly it is a very powerful greenhouse gas. So H2 is a very powerful greenhouse gas. That is the most important factor of water vapor, the formation of cloud. You can just write down the formation of, it helps to form the cloud. Then it helps to, it has a very powerful greenhouse gas. Then carbon dioxide, it is very important for photosynthesis. It is also a greenhouse gas, and it is a variable gas within the atmosphere, which depends upon its variability depends upon human impact. Anthropogenic cause, what we say, anthropogenic cause, because of that the amount of carbon dioxide varies within the atmosphere. When it comes to methane, methane is very less. It is very less within the atmosphere. It is also a greenhouse gas, but it helps to store the ozone layer also. So carbon dioxide, H2 and CO2, both all are greenhouse gases. So methane has, you can say, least concentration, then carbon dioxide, then water vapor. So these are the variable gases. Then we have those dust particles that from volcano, what we call aerosol. Then ocean splash, sea splash. These are formed when wind, the friction of wind over the ocean surface. Also formed when a wave that bombard on the shore. In that condition, splash of water or small molecule of water that enter into the air or atmosphere. Another thing, your ozone. Obviously, ozone is very important. It absorbs all the UV rays. Almost 97% to 98% UV rays will absorbed by the ozone layer. Then another important is CFC. So it destroy the ozone layer. So how ozone helps to protect from us from UV layer, UV rays, and how CFC will destroy that. We'll discuss in the latter section. Aerosol particle is also very important for cloud formation because water droplets they condense on the smaller dust particle. Also smog that happens because of aerosol. So these are composition of atmosphere from which most important thing are permanent gases, then greenhouse gases. Those are the important ones. So you have to remember which gases are greenhouse gases and what are the different permanent gases. When it comes to layers of Earth atmosphere, so Earth is classified into four or in some part you'll find five layers. In the troposphere, stratosphere, mesosphere, thermosphere, then exosphere also. So there is no, you can say, upper limit of atmosphere because it is not determined at what density level we would say that this is atmosphere. Suppose as we go up, the density of the atmosphere will decrease. So there is it is not certain boundaries are set. This much of density should be considered as the atmosphere. डेंसिटी कितना होने से उसको तुम एटमॉस्फेयर बोल सकते हो देयर इज नो सर्टेन पैरामीटर सो दैट्स व्हाई देयर इज नो अपर लिमिट ऑफ द एटमॉस्फेयर so above thermosphere or above exosphere we say that is atmosphere but there is no upper limit at the bottom it is earth surface. We start from troposphere, then stratosphere, then mesosphere, then thermosphere. Each are divided by a pause. These pause are because of constant temperature. Each atmospheric layer they are separated by constant temperature. So those separation layer those are called as pause. So these are this is the temperature profile. You can say this is troposphere. From troposphere, the temperature decreases as you go up. Then, in between the layer between troposphere and stratosphere, the temperature is constant, and that layer is defined by tropopause. Then again increases, then again decreases. So alternatively, you can easily remember how the temperature regulates in the atmosphere. With altitude, first in troposphere it will decrease, then stratosphere it will increase, then mesosphere it will again decrease, then thermosphere it will again increase. And they all are separated by constant temperature field, what we call tropopause, stratopause, and mesopause. Understood? Then comes to troposphere. Troposphere it is the lowest and thinnest layer, but it is also the major important layer. It is approximately 16 to 18 kilometer at equator and 8 kilometer at pole. Polar region it is thinner and in equatorial region it is thicker. So as we go up in the troposphere, temperature decreases, that is called as lapse rate, which is approximately 6 degrees centigrade per kilometer. So it is also called as your temperature inversion. troposphere show temperature inversion. It is because of the radiation or conduction. The lower part of the atmosphere got heated because of conduction. So when the sun ray comes, it is absorbed by the land. Then when it will radiate, it will heat, or it will by conduction you can say, or by radiation, it will hit the lower part of the atmosphere, and that heat will decrease upward in troposphere. That we will discuss in heat budget. It is very important for atmosphere. It is very important for weather, because all the weather activities that occur within the troposphere, cyclone, anticyclone, storm, precipitation, all occur within the troposphere. And stratosphere is more free from weather, so that's why all the, you can say, uh, aeroplane or flight, those are all operate within the stratosphere. Troposphere is very disturbed for weather phenomena. So these are the characteristics of troposphere. It is 60 kilometer at the equator, 8 kilometer at the pole. Then it constitutes also 90% of the atmospheric mass, because that will indicate the more denser part of the atmosphere is concentrated to the troposphere. Then temperature inversion is occur within the troposphere. Then the radius will be 6 degree per kilometer. The lapse rate, the temperature will decrease 6 degree per kilometer, and then it is separated from the stratosphere by tropopause, where the temperature is constant, and all the atmospheric convection that happen within the troposphere, that stops at tropopause, and it is marked by constant temperature. So it is extend from 10 kilometer to 50 kilometer of the ground, which is less dense, and obviously this layer is free from. It is important. It contains ozone zone, and it is free from clouds and weather. So all the aeroplanes or flight, they prefer stratosphere. Mostly lower stratosphere. Sometimes lower stratosphere also affected by the weathering phenomena within the troposphere. So sometimes in upper stratosphere is also prefer for the flying, and it stops at stratopause. The boundary between stratosphere, the boundary of the stratosphere, upper boundary of the stratosphere is stratopause. So this is the important thing about stratosphere. Most important thing is contain ozone, and second, flying activity. So troposphere and stratosphere. There is ozone layer extend from troposphere to stratosphere. What is ozone layer? We discuss in the latter section. Then comes to mesosphere. It extends almost up to 80 kilometers. So these are very least important layers. The gases are very less dense, and it is also show temperature inversion condition. So temperature decreases as altitude increases, and there are very less gases, so there are very less absorption of UV ray within the mesosphere. All the UV rays, they are absorbed after that within the ozone layer, within the stratosphere. The important thing is meteorite can burn within this layer. So when it will enter to the mesosphere, it starts to burn. Then comes to thermosphere. So above mesosphere, it extends up to 600 kilometer high. Temperature will increase here. So it absorbs some of the solar radiation. Temperature is very high here, 1500 degrees centigrade. So you can say ionosphere, where charged particle activity is more. It is a part of thermosphere, which is between 80 to 400 kilometer. So because this ionosphere, aurora are observed within the North Pole and South Pole, or within the magnetic pole, you can say aurora australis, aurora borealis. They are formed because of this ionosphere, because of this charged particle that occur within the ionosphere. The important thing in thermosphere is the formation of aurora because of this presence of ionosphere. Then exosphere, as there is no certain top limit of the atmosphere, so height above 400 kilometer are considered as exosphere. There is no upper limit of exosphere. Pretty more extremely less dense air very less dense air, and also temperature gradually increases through the layer. So you will also find gases from the outer space, the helium and hydrogen here, and there is no such important thing about this layer. Only remember the temperature will increase in exosphere, and is the, we can say it is the topmost layer of the atmosphere. Then also ozone layer. It is a very important layer. Ozone layer it consists of O3. So how it helps to, to absorb the UV rays. So on the upper atmospheric layer, there are oxygen atom. There are oxygen atom. When sun ray falls on the atom or UV ray falls on the atom by process of photolysis, two oxygen atom combine themselves. Oxygen atom combine with O2 to produce O3. That's how ozone will form. So oxygen atom will combine with O2 to produce O3. So in this process, by this photolysis process, the UV ray it is absorbed, and in the expense of the UV rays, O3 will produce. That's how UV rays are absorbed and O3 will produce. Again, UV ray can break down O3 to produce O2 plus O. Then again, this O will combine with O2 in the expense of UV to produce O3. That's how this reaction occur within a cyclic manner, or you can say the cyclic manner. You can say not exactly chain manner. In a cyclic manner, these reactions are occur, and all the UV rays are absorbed within that layer. But this O3 it is formed within the ozone layer and within the upper part of the troposphere or lower part of the stratosphere, which approximately from 19 to 35 kilometer is the ozone layer thickness. Then these O3 they are attacked by CFC, chlorofluorocarbon. So chlorofluorocarbon is very inert depends. CFC is very inert, so it will only break down on the sunlight. So when CFC will break, it will produce chlorine. Now this chlorine is very harmful for O3. So first this chlorine it will react with O3, it will break the O3, produce chlorine monoxide plus O2. Then what will happen? This chlorine monoxide it will react with the oxygen atom. So when it will react with the oxygen atom, it will produce Cl plus O2. Now again this Cl will again react with O3 and this reaction will again continue. It also occur in a cyclic manner, and that's how it will destroy all the O3. Chlorine, those are chlorine, bromine, those are mostly very bad for, you can say, ozone layer. So that's how they destroy the ozone layer. So these are the different layers of atmosphere. So troposphere, stratosphere, mesosphere. So troposphere is very important for weather phenomena, temperature emission occur there. Then troposphere, stratosphere boundaries, tropopause. Then stratosphere is for flying aeroplane, and it is where temperature will increase. Stratosphere. It contains ozone layer, which absorbs all the UV rays. Then your mesosphere, then thermosphere, then exosphere. So these are different layers of atmosphere. So what is Earth's heat budget? So the amount of heat that received or come to the Earth through the atmosphere is also reflect back to the space. So that is your Earth's heat budget. The amount of solar radiation that come through the atmosphere, that is called as your insolation. Insolation. The short form of, you can say, incoming solar radiation. So if incoming solar radiation, if you consider 100%, then Earth will reflect back all the radiation. That is called as a solar radiation. जितना आएगा उतना वापस भी जाएगा, reflect होगा. So the return process, it is not only by reflection. There are several processes that is determined by Earth's heat budget. What portion of reflection and what portion is by conduction or what portion is by, you can say, radiation. If we consider incoming solar radiation 100%, then that's how only 47 percentage that can pass through the atmosphere and it can be absorbed by land or ocean. So from the incoming 100% solar radiation, first 23% is absorbed by air, H2O, ozone, cloud and dust. And 17% is reflected by cloud and 7% is it is reflected to the space or it is scattered to the space. It never come to the atmosphere. Then 6% of the solar radiation is reflected from the land. As you see, from 100%, only 51% solar radiation, 47 plus 53%. 53% of the solar radiation that actually reaches to the Earth's surface. 53% reaches to the Earth's surface, and your 30 plus 70, 47%. It is reflect from the atmosphere, or it is absorb or reflect from the atmosphere. So only 53% that can actually reach to the land or ocean part or to the earth surface. On the 53%, 6% reflect instantly reflect back to the surface, back to the atmosphere, and 47% it is absorbed by ocean and land. Then from the 40%, 47% that is absorbed by land, that is also try to escape in various process. That is, one is conduction, one is phase change, or you can say latent heat, one is long wave radiation, you can say infrared radiation. So conduction means atmosphere it is in contact with the earth surface, so there will be conduction. So heat, only 7% of the heat can be escaped to the atmosphere by conduction. Then latent heat by phase change. When evaporation occurs, in that condition, evaporation condition, liquid it converts to gas. When liquid convert to gas, then heat is required. It is required. So 24 percentage of the of all the absorbed heat, they are reflected to the surface by latent heat or phase change. So this is your latent heat. So when the solid will convert to liquid, then heat is required. So when solid converted to liquid, heat is required, but the temperature will remain constant. So at constant temperature, there is an increase of heat, or heat will be added with constant temperature. So it will convert to liquid. That is called as latent heat of fusion. Then in liquid condition, it is called as latent heat of vaporization. So to convert liquid to gas, you have to add heat. You have to add heat. So during evaporation, heat is added, then that heat escapes to the atmosphere. So that's how latent heat or phase change escapes to release the heat from the earth surface. जो ऑब्जर्व हीट है वो latent heat of vaporization के through atmosphere तक जाता है. So it will escape to the atmosphere with the help of phase change, with the process of, you can say, evaporation. Then the heat that is contained within the vapor, it will release when it will again convert it to liquid form. So when gas will convert to liquid, then heat will release. So when there will be rainfall, all the heat that is within this cloud, it will escape to space. So that's how latent heat will help to release the absorbed heat from the land part or ocean particles. Understood? So that is contribute that will escape 24% of the absorbed heat. This is a major, you can say, heat release. Major absorbed heat is released by latent heat. So major part of the absorbed heat, it is released by latent heat or by phase change. Then rest of the heat, it is released by longer wave radiation, particularly infrared radiation. So it is constitute up to 16%. So from 47% of absorbed heat, 7% is by conduction. It is released by conduction. 24% it is released by latent heat or vaporization, you can say. Then 60% by longer wavelength. So only 10% can escape into the atmosphere. Only 10% will escape into the atmosphere. The rest of the percentage, they are again absorbed by the cloud or greenhouse gases, you can say. Here comes the greenhouse effect. Because the radiation or radiating heat, it is absorbed by the ozone, cloud, H2O, CO2, all these gases. Those are gradually also radiate from the cloud, or it will radiate from H2O and CO2 to the atmosphere. From cloud, it will radiate when rainfall occurs. That's why when rainfall occurs, you will feel cold. So from 47% now we have 10% directly exposed to the escape to the space. Now we have 37% trap here. 37% trap here. And during incoming, the cloud also absorb 23%. The total is 60%. 60% it is actually contained within the cloud and all other gases, H2O, CO2. Then all will gradually radiate. So it's 20% and 60%. So from 100% incoming solar radiation, 30% by reflection, 40% and 20% by radiation, can say. Total हो गया 90%. Then 10% by longer wavelength radiation, which हो गया 100%. 100% incoming solar radiation and also 100% escape to the space. एक बार अच्छे से डायग्राम देख लो, डाउट होगा तो पूछ सकते हो. When solar radiation, that is electromagnetic radiation, that passes through the atmosphere, so those wavelengths are very less. You can say smaller wavelength. So H2O, CO2 cannot capture much of the amount of radiation that is coming from the sun. But when it is absorbed at the atmosphere, at the land part or ocean part, it will radiate it as longer wavelength. So that longer wavelength, it is captured by H2O and CO2. So you can say that shorter wavelengths are transparent to H2O and CO2, but longer wavelength, it is captured by H2O, CO2. So that is also called as a greenhouse effect. Then comes to differential heating of Earth, because Earth is not a flat structure. All part of the Earth will receive same amount of radiation or same amount of intensity of radiation. The Earth is a spherical surface. So solar radiation will heat the equator at, you can say, vertically or to the other region at an angle. So here comes another effect that is called albedo. Albedo is the reflective capacity of a substance. कितना रिफ्लेक्ट होता है एक सब्सटेंस से, that is called as albedo. जैसे इंसुलेशन होता है कितना ऑब्जर्व होता है. सो जो ब्लैक बॉडी होता है, so black body it has greater insulation and they have zero albedo because the black body can absorb all the radiation. But if you consider ice or glacier, they have greater albedo and very less, you can say, insulation. And also albedo depends upon the angle at which the radiation falls. If it is fall on greater angle, the albedo will be more. If it will be fall in a lesser angle, the albedo will be less. So that's why equator part will receive more heat. It can absorb more heat than polar part. That is called differential heating. Polar is also consisted from ice and glaciers. So much of the heat that is reflected back to the space. So they cannot absorb as much amount of heat as equator will absorb. Equator means it is actually tropics because our Earth is also tilted 23.5. So that's why there is a temperature difference between the equatorial part and polar part, which will drive the global atmospheric pattern. Global atmospheric pattern. So wind or heat from equator, it will rise and move towards the pole. That also helps to regulate the temperature. Otherwise, the central part or equatorial part will be more hotter and polar part will be more colder. So relative temperature is maintained because of this atmospheric circulation, so which we will study in the next class.